Hey, it's Dr. Astar Bear, and in this introductory video, we're going to be talking about what is economics and how do we go about creating knowledge in the field. Okay, so economics is a theory, right? And like all theories, it's an attempt to connect and to understand the nature of cause and effect. All right, so like anything, we want to understand how it works. Right? We want to understand how the economy works. We wanted to understand how a living organism worked. Whatever it is that we're trying to understand, we want an understanding of cause and effect relationships. But again, like all theories, they confront a difficulty. All right, we could call this the problem of knowledge. The problem of knowledge. Okay, the problem of knowledge is, how do we know it's true? How do we know that our theory, whatever it is true? All right. Now we could ask other questions about this, right? Like, what do we mean by true in a grand sense? What is that? Right. So we are getting into here a branch of philosophy, which is called epistemology. Right, and epistemology is concerned with the study of knowledge itself, right? Dealing with these questions: what is theory? What is the nature of cause and effect relationships? How do we form a body of knowledge? And how do we know that that knowledge is true? What does it mean for something to be true? Right, all of that is under the heading of epistemology, okay? And every field has to deal with these questions, right? I mean, it's very easy to create a story about cause and effect, right? The hard part is to know whether or not that's true, to be able to show that it's true, right? So now we're getting into this topic in more detail, right? Um, so we notice that there's two basic kind of approaches to this. Okay, I'm going to talk about the first one a little bit more detail. Okay, this is called essentialism. Okay, so when we go to study theory, to study knowledge, whether it be in economics or anything else, we often arrive with this kind of understanding, right? That falls under this heading of essentialism. The idea that things have a fixed essence, right? They have an inner nature. Okay, so example, right? I mean, in the social sciences, you often hear this thing called human nature described, right? Now, what is that, right? Is this not the idea that human beings have some kind of fixed essence within them, right? That the thing which every human being shares with every other human being, despite we know that everyone's different, right? But human nature means, what does everybody have in common, right? And you can kind of see, well, that's a very compelling idea, right? That's an idea that is very much part of our culture, right? Like, there's a song called "Human Nature." You look that up. Uh, the thing is, we know what that means, right? You just say those two words, human nature, and everyone already knows what you're talking about, right? That's because this kind of essentialism is a very deep part of our culture. It's very deeply interwoven in how we think about pretty much everything, right? So the job then of a theorist, or of economic theory and any other kind of theory, would be to uncover this essence, right? So the work of science, or of theory in general, would be to, like I say, uncover the essence. It might be covered up. There might be other things that are obscuring our understanding. We can't see things accurately because there's a cover over it of some kind, right? So we're going to pierce that cover, we pierce that veil, and then we will get to the true understanding. Okay, so essentialism. Um, okay, so when we look at like I said, very very strong part of our culture. Okay, well, when we look at this question, like I said, the problem of knowledge, how do we know it's true? how do we know? Right? The essentialists give us basically two different answers, okay? And these answers have kind of been in competition with each other over the years. Right? Number one, we could use the scientific method. Use the scientific method, right? I don't know if you can see that this is in fact an answer to the question, right? How do we know? We know because we've tested it, right? We know because science, right? I mean, it's a big answer in our culture, right? Our culture is very, very impressed with the scientific method, right? Every single person who's educated in a Western society studies the scientific method, right? You have to learn how to conduct an experiment and what are the possible problems that could arise when you do an experiment and so forth, right? So the scientific method takes us to the truth, right? Or at least eliminates those theories that are false, okay? So this is also called empiricism, right? Empiricism, because the scientific method is also known as the empirical method, right? So scientific method or the empirical method. Empiricism is the belief that we can obtain the truth, we can get to the truth, right? The true, whatever it is, right? True theory, true cause and effect relationship, by using the scientific method, okay? That is the evidence of our senses, the scientific method, all right? Scientific method is just a formal way of structuring observation, all right? So let's just, I know we've all had this before, like I said, very much part of our culture, we've all studied it, right? But the scientific method proceeds in these steps, right? The steps of it are, you're going to first create a hypothesis, okay? And a hypothesis, okay? A hypothesis is just a statement about cause and effect, right? It's so the statement about cause and effect. All right, and the important part about this is it has to be something that is actually testable, okay? So we create a hypothesis, and then we are going to test the hypothesis, right? And in the classic description of the scientific method, we're going to test that by creating two groups. Right, these two groups are the experimental group and the control group. Okay? And these two groups, very important, right? They have to be identical except for in one respect, right? So, like this name implies, right, control. We have to control all of the variables, all of the things that could possibly change have to be the same between these two groups, right? So there is one variable that is different, okay, that is called the experimental variable, right? But that's the only one, right? There's one experimental variable, right? And however many variables there are in this system that we're studying, that we're trying to understand, we are going to control every single one of those variables so that they are the same between these two groups, except for that one, right? Except for that one, okay? And then we are going to, this is how we test the hypothesis, right? We're going to either, reject or fail to reject the hypothesis based on the results of this experiment, okay? So we reject the hypothesis if it's not consistent with the results, okay, of the experiment. And of course, we might then have to repeat this process. Others might need to repeat it because there's all sorts of things that might go wrong, right? An experiment that's done one time, okay, that's good, right? We didn't reject the hypothesis, but we need to do it again, right, in order to establish maybe that was an accident, maybe there was some other thing that we didn't even know there was a variable, right, that interfered, right? So these are the steps of the classic scientific method, right? So let's just make sure we understand this, right? Let's say that the theory that we're trying to test is, okay, so example, that some germ, right, germ X causes disease Y, right? So look at this. We have a statement about cause and effect, right? We could even describe it in symbolic terms, right? Our hypothesis is that X causes Y, okay? So a cause and effect relationship, and we can describe the relationship in symbols, right? That would be very different than if the arrow went the other way. That would be saying Y causes X, right? The disease causes the germ. So that's not what we're saying, right? We're saying here's the cause, here's the effect, okay? Now to test that, we're going to create two identical groups, except this one is going to have the germ present, and this one is not, right? So in our example, right, X is going to be present in the experimental group, but not in the control, right? So X not present. Right, and when we say, is the result of this consistent, okay, with our hypothesis, yes or no, right? Well, what would that mean, consistent, okay? What it would mean is, look, if we have the germ present in this, let's say it's a cell culture, right? It's two identical cell cultures. It's a situation where this works pretty well, right? So two identical situations, we can control everything except this one we get the germ present and this one we do not, right? So what would cause us to reject this, right, is, okay, so reject if, right? Let's say this happens, okay, the disease occurs in the control, right, and in the experimental group, right? If it occurs in both, well, it occurs whether X is present or not, right? This is not consistent with our hypothesis, right? Or let's just say maybe the disease occurs only in the control, right? That would also not be consistent, right? It doesn't occur in our experimental group where the germ is present. Does occur in the control, right? That's going to be a reject, right? Uh, let's say that the disease doesn't occur at all. All right, doesn't occur in a control, also doesn't occur in the experimental group. Okay, all of these would give us cause to reject the hypothesis, right? What would cause us to not reject it, right? To fail to reject it? Well, if we had the, like we set up, like I said, right? X is present, and then we get the disease in this experimental group, but not in the control, right? So that would cause us to fail to reject, right? Disease present in the experimental group, absent in the control group. Okay, so these are the steps of the scientific method, and I think you guys will agree with me that this is very, very important, right? I mean, especially we look at about the last 300 years or so, right? The last 300 years is a period where the scientific method, as an idea, as a way of gathering knowledge, rises and rises in terms of power and prominence until we arrive today at the place where, we basically, like, all we have to do is say it's science, right? And then what are we doing there, right? We're in just a shorthand, just by saying that one word, right? We are talking about this entire argument here, right? That by creating experiments in the way that we've laid out, right, then we can get to the truth, right? We can separate that which is true from that which is false, right? So that is a very, very powerful argument, right? Now, it's not the only thing that our culture gives us as a way of establishing the truth, right? So let's go on and we'll talk about other ways we might arrive at the truth. Okay, so our number two method here is actually far older, all right? When we think about how do we know something is true, how do we get to the truth? Okay, our other way is that we use logic or reason, okay? And the ultimate form of the use of logic or reason would be that we would create a proof, okay, a logical proof, all right? And this is really brought to its kind of ultimate end in a couple of fields, right? So you see this in mathematics, right? Math is a highly logical, right? Everything in math is built on formal proofs, okay? And there's other like analytical philosophy, for example, is similar to this, right? It uses a language of symbols, and those symbols express variables and relationships and allow us to formally prove, right? If this is true, then that is true. Okay, this is what logic allows us to do, right? It allows us to say, look, if A is true, okay, whatever that is, right? A is our, whatever kind of statement this is, right? This is our initial assumption, okay, our a priori, right? So if A is true, right, and if we follow the steps of logic, okay, we create a chain, a logical chain, right? If this, then that, then what follows after that, right? So if A is true, then B is true, right? That's if this, then that. Okay, that's logical inference, and that is the cornerstone of the use of logic, the use of proofs to show that a proposition is true logically. Okay, so this is a very old one, right? This goes back to the ancient Greeks, right? The ancient Greeks were very into this idea. They were not really into the scientific method very much, right? They were into this, right? The idea that you could come to transcendent truths, right? Essential truths through nothing more than logic, right? And this was developed over time, right? Again, it's part of the Enlightenment, so the same movement that brought us the increasing prominence of the scientific method also brought us the development and refinement of this idea that we could use logic or reason in order to obtain the truth. Okay, so philosophically, this is known as rationalism. Okay, so again, the idea that so it's part of essentialism. Okay, the idea that things have a fixed essence, right, and that the job of logic is to uncover that, right, and if we can get to that, then one of the ways that we know that we're at it, right, is the idea that look, true statements, okay, or true theory, right, is going to be free of logical contradictions. Okay, here's the thing, right? Normally, when we go about making arguments, making statements, it's pretty common for some of those statements to contradict each other, right? Or to not all be going in the same direction, right? So, people say a lot of things, right? They say this, that, and the other. What if you at first start off by saying A causes B, but then later on in your argument, you end up saying that B causes A, right? Well, this is obviously a contradiction, right? So someone trained in logic, you don't have to go very far in logic, right? It would say, well, which of these statements is true, right? They can't both be true, right? Because again, we're proceeding under the understanding that things have a fixed essence. Okay, so A is A, right? This is called the law of identity in logic, right? That a thing is itself, right? Meaning it has an inner essence. This is why it's possible for us to say, look, there's either A or not A, right? We can separate the world into everything that is A and everything else, right? So these are the kind of fundamental rules of logic. Now, obviously, there's whole classes in logic, and you guys should take it, right? Very powerful tool. This is not a class in logic, so we're not going to get into the details of it, right? I just want you guys to understand it in general because this idea is very, very strong in economic theory, okay? Economic theory uses a lot of math, right? A lot of math, and it uses it much more so than other parts of the social sciences, okay? So, look, odds are maybe you guys have taken some other social science courses, okay? Maybe you've taken sociology or anthropology, or maybe you've taken psychology, or all of these these are areas which have some overlap, right? They're studying human behavior, the human mind, human societies, right? All of these have overlap with economics, but it's likely that the courses that you took have much less math in it than an introductory economics course. Economics courses you'll see are full of graphs and equations and mathematical reasoning, right? Why? Well, it's because of this idea, right, that if we want true statements about anything, right, about the economy or anything else, these statements are going to be, if they're true, they're going to be free of logical contradictions. And what's the best way to discover that? Well, a proof is just a formal mechanism for ironing out and eliminating all kinds of logical contradictions, which again are very, very common in arguments of all kinds, right? So again, very old idea, right? Thousands of years old. This idea that we can use logic to get the truth is probably 2,000 years old, right? This has a longer history than empiricism, but there's a kind of a conflict, right? These are different ways of approaching the truth. Okay, logic proceeds by starting with propositions and then following them through to their conclusion logically, right? You don't necessarily do any experiments when you're doing logic, right? Like, you know, in math class, I don't know if you know this, you don't do too many experiments, right? Or mathematicians do not do experiments in general, right? They follow through the logic of their propositions, right? That's very different than, the empirical method, right? The empirical method does not proceed on the same basis, okay? So, and sometimes these two have clashed over the last few hundred years, right? Especially as the scientific method has grown and grown in prominence. Okay, so we find that there are differences, there are disagreements between those who believe in this, right? The rationalists versus the empiricists on the other hand. Okay, let's talk about some of the limitations, right? The scientific method is a fantastic tool, right? And it's brought us tremendous advances in our knowledge, but it has certain limitations, okay? So there are certain areas, right, where the scientific method, or times and places where the scientific method doesn't really work well, right? So let's just discuss that, okay? So the scientific method, as good as it is, doesn't work when you can't control the variables, right? So again, the word control is very, very important when we're understanding the scientific method. If we can't control the variables, if we have a situation where the experimental group and the control group differ in more than one respect, we can't really proceed, right? If it's not possible to control the variables well enough to make sure that they only differ in one respect, we're not going to be able to use the scientific method, right? The scientific method is going to give us very contradictory results, all right? So now, unfortunately, of course, that is our situation with economics, right? We can't possibly create, we can't have this, right? We can't have an experimental economy and a control economy, right? Can you imagine, right? How would that work, right? We want to know if this economic policy has this particular effect, right? We're trying to understand the difference between cause and effect, right? What causes things to happen in the economy? Well, can we do this, right? Can we have an economy that is identical in every single way except for one, right? Well, no, of course not, right? That's impossible. That's never been done. What would that take? We would clone everybody and make sure that they all do the same thing except for only one difference, right? It's impossible, right? It's an absurd fantasy, right? We can't possibly do this, right? So I've got this, right? Impossible. Can't be done. Okay, so because of this, because we can't really do this in real life, and every economist knows this, right? There's no disagreement about this. We can't do this, right? We like to kind of pretend we can, all right? So we use this Latin phrase, ceteris paribus, all right? Ceteris paribus. It means holding all else constant. And this is like pretending that we can do the very thing that I put the x's through, right? We can't possibly do that, so we pretend we can, right? So you'll see this phrase invoked quite a bit. Ceteris paribus. This is, this is going to happen if everything else is held constant, right? So this is kind of a nod to logic as well, right? To saying, well, when we make assumptions, right, we assume that one variable changes. We assume that's the only change, right? So that we can then identify the effect. Okay. This is unlikely to produce very good results, right? I mean, we could do a kind of slapdash version of it, right? I mean, like, what would we do if we wanted to do that? Could we say, all right, our experimental economy is the United States and our controlled economy is Mexico? Well, the problem here is obvious, right? I mean, the problem is these two societies differ in more than one respect, right? How do we know, like, let's say that we're trying to study this, right? Let's say we're interested in this question, okay, tax cuts, does that lead to economic growth? Okay, that's our question, okay, cause, effect, right? Well, perhaps the United States has done tax cuts. We actually have recently, right, the Trump tax cuts, and Mexico has not. What happened, right? Well, the problem is lots of things were different, right? I mean, we don't even know how many, right? Thousands or millions of things are different between these two countries. We cannot control it, right? So we're not going to get good results in this situation, right? It doesn't work when you can't control the variables, and we all learn this, right? We all learn this in grade school. My kids are in grade school. They learn about the scientific method, right? Anybody who had a Western education did this, right? You had to set up an experiment. Okay, so it does not work when you cannot control all the variables, right? And the problem is there's lots of interesting things that don't really lend themselves to controlling all the variables, right? Um, we the ideal situation for us to use the scientific method is when we can control, when we can isolate, right? When we can, when we can perform analysis, right? The word analysis means to take something apart into its constituent pieces, right? And then to reassemble it. That was synthesis, right? To put the pieces together, right? So when we can do this, we're going to find the scientific method is going to give us very good results. But when we can't, we are not going to get good results, right? That's one of the difficulties. That's one of the limitations that we confront. And so you can see that this is kind of a problem for us, right, with economics. Our main tool that the culture gives us in terms of how do we know something is true, well, we can't really use it, right? And if we use it, we're only going to be able to use it in a very incomplete fashion, right? I mean, there are lots of studies that compare, for example, the United States and Mexico, and that try to control all the variables using advanced statistical techniques, regression analysis, and so forth, right? They try to control the variables, but if you really push someone, did one of these studies and say, are you sure that you've controlled every single variable? Are you sure that you've measured every single variable between these two entities? They would have to say no, right? I mean, because how could you reasonably answer yes to that, right? Like, even if you looked at 200 variables, well, are you sure there's not 500? No, I'm actually pretty sure there's probably more than that, right? 200 is all I had data on. Well, does that make it true, right? Just because you have data on a piece of it and not the rest of it? Not necessarily, right? Okay, so now limitations of the scientific method. Okay, let's talk about limitations of logic. Okay, so logic, the use of reason, right? The rationalist approach. Logic is going to work well when we can identify all the variables and the relationships, and when they stay the same, right? So logic assumes, again, that each variable has, like I said before, a fixed essence, okay, and that essence doesn't change, right? The variable can take on different values, right? But it does not fundamentally change in its essence, okay? And the same thing is true about the relationship between these, right? The variables and the relationships are what they are, right? They are fixed, okay? They have a fixed essential nature, okay? So in order to understand what I'm saying, right, let's just take a common logical problem, okay? Now, by the way, you've all been trained in this, right? This is on every single standardized test, right? You take the SATs or the ACTs or anything, right? The LSATs, any kind of standardized test is going to have logical problems on it that you have to solve given the information, right? So that they can test you and see, are you able to make logical inferences? Okay, so let me give you an example of one of these logical problems. Okay, so here's you're traveling, right? You're taking a journey, okay, and you encounter a river, right? It's a drawing of a river, all right. And on this river, there or next to it, there's a boat, okay. And here's you, right? You're traveling with these items, okay. You've got, the kind of items that everyone takes with them. You've got a big bag of wheat, okay. You've got a lion. All right, I'm drawing kind of a bad version of a lion here, but right, you've got a lion, and you have a goat. All right. You can see I did not prepare for this in advance. Okay, wheat, lion, and a goat. All right. Now here's the problem, right? The problem is you need to get across this river, but the boat is very small. The boat allows you to take. You can only take one thing with you, right? You can only take one thing. Oh my goodness, what do, right? Um, and the okay, you're going to have to take several trips, right? But again, you've got a difficulty, right? The difficulty is if you leave the goat and the lion alone, you're going to have a problem, right? Lions eat goats. The only thing that's preventing the lion from eating the goat right now is you. But if you're gone, if you're on the other side of the river, the lion's going to be like, it's chow down time. I'm going to eat that goat, right? So, and there's another difficulty, which is that goats eat wheat. So the goat is going to eat the bag of wheat. If you leave the two of them alone, what do, right? Uh, you've got a problem, right? I mean, because you could take you can't take the lion with you on the first trip, right? You see the problem? You're gonna be the goat's gonna eat the wheat, and okay, you could take the goat on your first trip. That's okay, right? Take the goat, but you still have a difficulty, right? Which is that what are you gonna take next, right? If you take the wheat next, the goat's gonna eat it while you're getting the third one, right? So this is a logical problem, right? And this problem, it has a solution, okay? It's a famous logical problem, right? It's got a solution. Uh, but in order to solve it, this is what your unspoken assumption is, right? Everything has a fixed essence, and these relationships, they are what they are, right? They do not change because the essence of the thing doesn't change, right? The essence of the lion is that it eats goats. The essence of the goat is that it eats wheat, right? If that wasn't true, by the way, you would not be able to solve this problem using logic, right? You need that assumption in order to conduct inference, okay? But that's not always true, right? Like, what if, see, the problem that critics of logic have pointed out, again, for thousands of years, is that if everything has a fixed essence, the question that arises is, how do things change? How do things actually change? I mean, like, and we notice that things do change, right? The identity of things changes, sometimes quickly, sometimes slowly. How does that happen, right? If they have a fixed essence, how do we understand the nature of change? And logic is, relatively speaking, kind of weak on this, right? Because again, this fundamental assumption that things have a fixed essence. Now, sometimes that's a good assumption, right? Sometimes the world seems to be that way, right? We could assume that. Sometimes that works, right? Now we're going to talk in a minute about what does it mean for something to work, right? What do we mean by that works, right? I'll return to that. Okay, so sometimes things change in their essence, right? Like like, okay, the goat learns kung fu. The goat learns kung fu. What has it done, right? Well, now it's like if you ever see Kung Fu Panda, right? Kung Fu Panda is like the idea that a praying mantis, which is like a really small insect, right? I mean, it's big for an insect, but it's a small for an animal, that a praying mantis can like learn kung fu and then beat up, like much larger animals, right? Uh, so the goat learns kung fu, and then the lion can't eat the goat anymore, right? So what we see how this violates the assumption, right? That the fixed essence of the goat has now changed, right? It's not fixed anymore, and the relationships that were attached to that essence also have to change, right? Well, now we've got a battle. Who's going to win, goat or lion? I mean, normally the lion would win, but the goat knows kung fu. Ooh, okay, yeah, I'm interested in this battle, right? Uh, okay, so you get the idea, right? If the essence changes, right, the logic, which was premised on these fixed variables and relationships, is not really going to be able to give us the answer, right? It's not going to deliver for us the truth, right? We will have violated one of the fundamental assumptions of logic, which is the law of identity, right? A thing is equal to itself. All right, so is we could go on a little bit here as well, and we can also say one of the limitations of logic is that logic, this is called the regress problem. Okay, if logic is telling us, look, if A, then B, like that, right? That is the basic structure of a logical argument. Okay, if this is true, then that is true. Well, the problem is, how do we know A is true? How do we know A is true? Okay, all logic can say is if it is, then this follows. But would we not have to go back, right? That's what the term regress means. Would we not have to go back and say, well, okay, A is true because of this other thing, right, that happened before? And the problem with that is you can never actually stop, right? Like, well, maybe something else, maybe some other variable, alpha or something, leads to A, right? But what causes alpha then, right? You can never really, it doesn't, you could say logic doesn't actually solve the problem of knowledge, it only displaces it. And say, okay, well, if this is true, then that is true. We've displaced the problem of knowledge. Okay, well, we know this is true if this one is, but we have not solved it in an ultimate sense. All right, so the scientific method and logic have certain well-known limitations. They are great tools, but they don't always give us the, the absolute truth, right? Okay, so if the scientific method and logic are our means of obtaining the truth, uh, what is our proof of concept, right? How do we know that our statement is true? Let's say, okay, it's logical, or it has, gone through the steps of the scientific method. We failed to reject the hypothesis. Well, how do we know it's true, right? Well, okay, this brings us to kind of the brass ring of essentialist theory, right? Which is, well, if the theory can be used to predict, okay, if it can predict what is going to happen accurately, well, then it's true, right? If a theory can predict, it works, right? Remember I said before, does it work, right? Can it actually predict what is going to happen, right? So let's say, for example, uh, a something which is designed to track time, right? Perhaps we want to create a machine that tells us, when certain events are going to happen, right? Like when is the year going to end? Can we create a simple machine that would give us this result, right? When is it exactly 1 year later? This is actually an ancient problem, right? People worked on this for a long time. These are some of the first clocks, right? And the first clocks were astronomical. They were sundials and things like this, right? About a day. But then they got interested in more detailed ones, right? Ones that looked at longer scale events. And so you wanted to know, well, can it actually predict, right? Is when this machine says that it's a year, is that true? Has it actually been a year, right? Does it actually work, right? Can it predict? Okay, so we could take an example from modern astronomy, right? Can modern astronomy predict, let's say, a solar eclipse? A solar eclipse, wow, that's an amazing event, right? You look up in the sky and the sun has been eclipsed. The sun has been partially blotted out. Wow, that's amazing, right? That doesn't happen all that often. That's an incredible event, right? Can modern astronomy predict when that's going to happen? Yes, it can, right? Well, so what are we saying then? It works. Look, I'm putting a green check mark next to it. It works. It can predict the motion of the stars and planets well enough. They can actually give it to us by the minute, right? To say, look, this eclipse is going to start at 10:21 in the morning, right? Boom. All right, so if it can predict, right? And even better would be if we can control, right? Can you take this machine apart and reassemble it? And does it actually work after that, right? Well, then you probably understand that machine, right? If you can take a car, take it down to its parts, put it back together again, and it runs, well, you probably understand some about cars then, right? You at least understand how the pieces fit together, right? And anyone who's ever taken something apart, this was me as a kid, if you've ever taken something apart and then struggled to put it back together, or you put it back together and maybe had some extra parts, that happened to me too. So, what are these extra parts doing? I'll sweep these under the rug. That's not good, right? Yeah, okay. So the question here: can you predict and can you control? Right? Can you use your knowledge to actually produce a consistent result? Right? So let's take a dramatic example. Let's take the example of a nuclear bomb. Right? Do you understand the nature of matter? Do you understand the bonds between the particles of matter and their relationships, their energetic relationships? Like, yeah, I do. I understand it well enough to set off a huge bomb. Okay, I agree. You understand it right now. Okay, you can control something. Boom. Yeah. All right. I agree. You don't need to prove it to me mathematically. Nope. That's fine. I don't need to see the proof. I saw the bomb. Right. That's good enough. Okay. So the brass ring, right? If theory can predict or control, well, then it's good theory. It works, right? But here again, we have a kind of a problem, right? The problem that we very quickly confront is that there are certain things that we're interested in where theory does a horrible job of predicting and it also can't control, right? So some systems that we study are simply unpredictable. They're unpredictable. And they also can't be controlled. They can't be controlled. Wow. So we might have theories about them, but these theories fail this kind of ultimate test, right? I mean, like, if I said, like, all right, you can predict and control, that's like the brass ring of scientific theory, right? So, well, what if you can't do that, right? What if you're dealing with something, look, it's just very unpredictable, it's uncontrollable. Well, what do? Do you give up? Or do you say, well, it's not a science or whatever? Um, you could, well, okay, give up, quitter. Right? But we still want to know how it works, right? We still want to understand it, okay? Now, why? Why are some systems unpredictable? Why can they not be controlled, right? Well, they have certain features which are aspects of complexity, okay? So we could call these kinds of systems complex systems, okay? And we could define what we mean by that. What we mean by complexity is something like this, right? Many variables and many relationships between those variables, okay? All right, well, that's fine, all right? There's just a lot going on. Okay, that would, aren't there things that are that have a lot of parts that we can still control? What's the key part of it is that we can't isolate them, right? That they are, in other words, very interwoven with one another. That we cannot take a thing out of its context very easily, right? It's either impossible, or if we did it, it would not have the function anymore. Okay, so we could look at, for example, the behavior of something like the atmosphere, right? The atmosphere has these features, right? There are many different variables, many different relationships, even though we're just talking about things like pressure changes and wind speed changes and directional changes and things like this, right? There's a lot of these variables going on. There's a lot of these relationships going on. The other problem is we just simply cannot isolate them. That is not meaningful, right? We cannot isolate a piece of the atmosphere and study it, right? We cannot take the atmosphere apart in that way, right? If we can't isolate, we can't really perform analysis, right? Like if we wanted to understand a clock, we could take a clock apart and study the parts if we didn't know what it was, right? That would be a good way of proceeding. But with the atmosphere, we're not going to be able to do that, right? We could take something like the ocean, right? The behavior of the ocean. Could we take a cup of water from the ocean and then study it and be like, I think I understand the ocean now? No, that's not the ocean anymore, right? Yeah, it's ocean water, but that you're not studying the entire thing anymore. You could do it. Yeah, you could take a cup, but you're not. That doesn't help you, right? It doesn't. It's not amenable to that kind of analysis, right? You just simply cannot isolate. Everything is too interwoven with each other, right? That does not help you, right? Now, the other problem with complex systems, or the difficulty, is because of their many relationships and so forth, you have contradictions within it that occur naturally. That is, the forces do not all lead in the same direction, right? You have other issues, which is that the entire system goes through change, and perhaps the variables and relationships are so interwoven that the nature of the variables themselves changes, right? Like the goat doesn't always stay a goat, the lion doesn't always stay a lion, things like that, right? The things change over time or quickly, their nature changes. Their fundamental behavior might change. Okay. Now I know this is getting kind of abstract, right? But bear with me because look, one of these systems that we're talking about is obviously the economy, right? The kinds of factors, the way that we're talking about this, right? This is all the case with the economy, right? There are many different variables. I mean, what's an economic variable? Uh, isn't each person and each institution a variable? Like, can it not take on different values? Sure. Well, how many of those variables do we have? We have hundreds of millions of them, right? We, because there's so many of them, because they're so interwoven, because they are contradictory and changing, we have a related problem that often occurs, which is that we can't observe the entire system at once, right? It simply is too. There's just too much complexity. We don't have the information. We can look at one piece of it, uh, but the problem is, right? There's a lot of stuff that we're not going to be aware of. That we're not actually studying, right? There is no place we can go and look at the economy. We can't go up into space and say, look down there, see that? That's the majestic economy. Fantastic, right? Going out into space doesn't help you, right? I mean, yeah, you can see a lot of land, but can you see what's going on? All of the relationships? Can you see the variables? No, right? So complex systems have these features, right? And this makes them, again, unpredictable and uncontrollable by their nature. Uh, Unpredictable and uncontrollable. Does that mean we can't do science anymore? We can't do theory? We can never understand the cause and effect relationships? Well, that sounds a little bit pessimistic. I mean, come on, let's try anyway, right? Um, okay, we're not going to be able to predict how things work, right? And by the way, can economic theory? I mean, if the proof is in the pudding, right? Like I said, right? Yeah, astronomers can predict when the solar eclipse is going to be. Can the economists predict the next recession? Answer, no. Not at all. Even the economists who study nothing but that are no better at predicting than anybody else, right? So if we look at can economic theory accurately predict events, uh, can it control events? I mean, let's say that you had control over an economy. Can you use your economic theory to control every aspect of it? Answer, no, not at all, right? So, no, very, very clear answer. And by the way, if economic theory could predict what was going to happen, there's no way on earth I would share it with you guys. I mean, come on, I like you guys, but if something can predict something, what's going to happen, then you don't share that, right? Because you want to use it. I would be not teaching economics. I'd be using it to get filthy rich, right? Which, by the way, I'm not. Um, Economics does not do a good job of predicting things. So we don't have that, right? We cannot say, well, maybe we don't understand it, but damn it, there's a nuclear bomb, right? Not the case. Okay, we cannot we can't use prediction and control to prove to everybody that we have a good theory. Okay, so the problem that I'm describing when it comes to essentialism is that we take what is evidently a complex system, we take complexity and we reduce it down. We assume that what we're dealing with is a simple situation, right? Something that can be described in terms of, say, mathematical equations. Mathematical equations deal with all of the assumptions that we've talked about so far, right? That we have variables, that we have the relationships between them, that those are possible to separate. So we talked about what are the characteristics of complexity of a complex system. A simple system would be the opposite of that, right? So a simple system has a relatively few number of variables and relationships that we can separate these. We can isolate them, right? Again, logic, the scientific method, works best when we can do that, right? It's going to have problems if we cannot carefully define all of the variables and relationships, if they change through their interaction, if they don't have a fixed essence, all the stuff that we just talked about, right? That's going to create problems for us, right? Simple systems don't have these features, right? There's few enough variables and relationships that we can separate them, right? We can analyze them, okay? We can take them apart, put them back together, right? Something that is not going to change as we do that, right? That's capable of being isolated, okay? So ideally, we can describe the variables and the relationships in the form of mathematical equations. We can describe in mathematical equations. Okay, so let's take an example. Okay, let me think. The simplest possible system that I can think of would be a pendulum. Okay, this is a weight that hangs from a fixed position. Right, we've got a string, and the pendulum goes back and forth. Right, so a pendulum fits all of this. Right, I mean it has variables and it has relationships within them, but they're very simple. Right, there's only a few. The main one is how long is this string, right? We can analyze this, right? We can describe it in terms of a mathematical equation. We have mathematical equations that do an excellent job of predicting the motion of a pendulum, okay? In fact, this was figured out a long time ago, right? And we built a simple machine. It's so predictable, right, that we could build a simple machine from it. And this is the basis of some of the first mechanical clocks, right? The clocks that, the first ones were sundials and stuff like this, right? But the ones that had moving parts used the motion of a pendulum, which was so well understood, so predictable, right, that it could be used to, create regular motion for a clock, all right? So these are examples of simple systems where all of the assumptions of logic of the scientific method give us excellent results. So since we've mentioned the topic mathematical equations, let's just develop this a little bit so we can kind of see what are we after here, right? So an equation, right, a mathematical equation is a way of describing a cause and effect relationship. Right, it's a way of describing a cause and effect relationship in very precise terms. Okay, so even if we have the most general form of this, okay, so we can take, for example, a mathematical function. Okay, the functional form specifies a cause and effect relationship. And just so that I'm sure you guys have seen the functional form before you studied this, but maybe you didn't understand it was about cause and effect. Okay, so a function is in this kind of format, right? We might say y is a function of x, right? So y equals f parentheses x, like this, right? Y is a function of x, right? And this format tells us something, okay? It tells us that the x variable is independent, right? And the y variable is the dependent variable, okay? This is just mathematical speak for the cause and the effect, right? So if something is independent, then it can do its thing, right? It does its thing first, right? It's the primary mover. That's what we mean. It's the cause, okay? Dependent, well, that depends. Y depends on what happens to x, right? X does not depend on y, right? That is a cause and effect relationship. We are saying, basically, right? X causes y, all right? So if we've laid out a function in this manner, it's actually saying something pretty profound and far-reaching, right? It is saying x is the cause of y, and there are no other causes, right? So if you think z causes y, no, you're wrong, right? X is the cause. Other stuff does not cause. That's a very profound statement, okay? So, and if we have the specific function, again, this one that I've laid out is called a general functional form, right? This is just general, okay? All it does is set up the relationship. And keep in mind, saying that x causes y was very different from saying y causes x, right? Now we could do that as well using the functional form, but that would be different, right? That would be x is a function of y, right? We can do that, right? There's functions that are like that. There's no law that says x has to be the cause and y has to be the effect. Not at all, right? By tradition, we use x and y, and a lot of us have learned it this way, right? That x is the independent variable and y is the dependent variable. It doesn't have to be, right? Okay, the point is the function describes a cause and effect relationship. So in economics, we use a lot of mathematical functions, and the idea is we want to describe cause and effect relationships in this concise and very clear manner, right? Where we've made it absolutely crystal clear. What are the variables and what are the relationships, right? That's the benefit of mathematics. The problem with it is it's very limited, right? The variables and relationships have to be very carefully defined. If we don't know what all the variables are, we're going to get garbage out of this, right? Everything has to be carefully defined, okay? That is the mathematical world, right? So we are, if we confront the messy complexity of the economy and try to put it into the form of equations, well, we might miss a few things, right? Some of our equations, we might not contain all the variables, right? So the dream of economic theory is that we could do this, right? Now, there's a difference between a general and a specific form, okay? If we say there's a specific form of a function, like y equals 2 plus 3x, all right, so now we have done, something different, right? We still have the functional form. If we said, y is a function of x, and here's what the function is, right? But now we have made it specific, okay? So, and of course, this is the linear expression, which has a y-intercept, okay? 2 is the y-intercept, and it has a slope. All right, the slope is the change in y over the change in x. It is the rise over the run. Okay, so all of this stuff I hope is stuff you've already learned. We're going to rely on that you know this in the course. If it's rusty, please brush up on it. Okay, this is what the math review, quiz, and the exercises on graphing are designed to help you with. Okay. Okay, so we're talking about the problems of assuming that our complexity is simple, right? There's a lot of different problems with that, right? One is we might miss some important stuff, right? We might miss some of the variables. Uh, we might not we might not include them in our model. We might not include them in our function, right? By the way, functions can have more than one variable, right? Like we could have a function that looks like this, right? Y is a function of x1, x2, x3, right? Functions can have as many variables as we want, right? So it could have n variables, right? So a common way to write this, right? X goes from 1 to n, right? N can be any number. There's that many variables, right? They're all independent variables, but y is a function of all these variables, okay? So we're not just limited to one cause. We can have many causes, but the important thing is they have to all be specified, right? Now, what if we miss some of them, right? What if they're not all specified? That's the difficulty of complexity. We have so many variables. Are we sure that we can tabulate each one? We can't even observe the entire system, right? Most of it is unknown to us. We might miss variables. We might create a model that is missing important stuff, right? We might take our complexity and reduce it into simplicity, okay? So this is the problem that is known as reductionism, all right? That is creating a simplified understanding, a simplified theory, saying this is the cause or these are the three causes of whatever it is we're trying to explain. We've missed the bunch of absolutism, right? Absolutism is thinking that we are absolutely right, okay? And you often see this kind of thinking, in the social sciences, often see it in economics, right? Thinking that your theory is absolutely correct. Other theories are absolutely wrong, right? Our theory has been proved. Other theories have not, for example, right? So the absolutism signals a belief in absolute truth, right? And what place would you have for those that disagree with you, right? You have the truth, others are wrong, right? You're living in a world of absolutes, okay, where there's right and there's wrong, right? Now, this is pretty unhelpful, especially when you're trying to understand something complex, right? Something that has all of these variables and whatever, right? How do you know you haven't missed some of them, right? Especially when you can't even observe the entire thing, right? Are you so sure that you're absolutely right and others are wrong? What gives you that certainty, right? And if you behave this way, well, aren't you being I don't want to say any bad words, but aren't you being an unpleasant person, right? Aren't you being a stubborn, annoying kind of person, right? That's absolutism. Okay, so if there's all these problems with essentialism, well, what's our alternative, right? Our alternative would be non-essentialism, okay? Non-essentialism. To say, look, there is no fixed essence. Well, I mean, or maybe there is, but we don't know what it is, right? So we will proceed by saying, look, there's no fixed essence. Okay. Now, there's just as essentialism has a long tradition in the social sciences and economics and philosophy, so too is there a long tradition of non-essentialism, right? So, what I think of as one of the prototypical non-essentialist types of statements is a very old one, right? Goes back to the ancient Greeks. Okay, the quote is this: "You can't step in the same river twice." Right? You can't step in the same river twice. This is an ancient philosopher named Heraclitus. All right, so again, I think of this as kind of like the prototypical statement, right? The nature of life is changed. That's what that seems to suggest, to me at least, right? The river is a flow of change. It's not the same river as it was. Maybe you're not the same. You stepped in the river. Ow, damn it, that was really cold. That water, I don't like that. I got my foot wet. I'm not going to step in that again, right? So you're not the same person that you were. Maybe you could make different choices, or maybe it has changed you, right? The experience, and try to emphasize, look, okay, the nature of things has changed. Expect there to be complexity. That seems to be the nature of life, right? Life is not simple, um, and anyone who thinks it is probably kind of a moron, right? I mean, like, you the more you learn, the more you understand how little it is you really know, right? Okay, so this means, look, we're going to be focusing on different things. We're going to be focusing on more the limits of our knowledge. Okay, it's like, yeah, we might know certain things, but there's a lot of things that are unknown. You know, we're going to focus more on ambiguity. We don't, things could be one way, or maybe they could be some other way, right? We're not so sure that we're exactly right. And by the way, this is less likely uh, to be absolutist, okay? Because we're acknowledging all of our limits, right? We're Are we going to be likely to say, well, no, damn it, I'm right and you're wrong? Probably not, right? That's less likely to occur, okay? Now it's a little bit more of a risk that we might become uh, relativist, right? We might start to think, well, every point of view is equally good or whatever. Um, and this can also be kind of a problem. This can also be kind of nihilistic, right? We could go so far in the other direction that we would miss that, well, each point of view actually has a consequence to it. They're not all necessarily equally good, right? We all have our ideas about what is good and what isn't good. Um, not everything is going to, not every set of ideas, not every theory is going to lead to an outcome that we think of as good. Right? So most of economics uh, is highly essentialist. Okay, highly essentialist. That is the kind of guiding focus of most of economic thought, and that seems to be a problem, right? Thinking that there's a fixed essence, you know, again, like, let's say we were skeptical of that, and we'd say, "Oh, you think there's a fixed essence? Well, prove it to me. Show me that there's a fixed essence." I mean, don't we all agree that the best way to show that you really have got the lock on the knowledge, if there is a fixed essence, you understand it, would be to predict and control? Oh, you can't do that? Well, maybe there's no fixed essence then. Maybe you're wrong about your approach, right? Maybe things are a lot more complex and free flowing than that. Maybe change and contradiction is more the way that the economy works. And if so, then you might want to take a look at this way of thinking, right? The non-essentialist approach. Okay, so economics, every introductory textbook proceeds in the same fashion, right? Like, one of the aspects of this, we get very into this phrase that we talked about before, right? Ceteris paribus. This is described in chapter 1 of pretty much every economics textbook. The idea that we can, hold everything else constant. Okay, and they'd like to insist that we can make a very clear distinction between what is called positive, okay, meaning what is, versus normative, what we think should be, right? So from this perspective, right, again, this essentialist perspective, what is, right, is the world of fact, okay? And what should be, that's the world of opinion. We can always be very clear about the difference between fact and opinion, right? Well, no, wrong, right? The problem with that is, yeah, look, that works when everything is simple and clearly defined. But that is not what we're dealing with the economy, right? The economy is the opposite of simple, right? It's highly complex. And is everything perfectly defined? No, not at all, right? So fact and opinion are not very easy to separate, right? So again, most of economics assumes we can do this, okay? So just to acknowledge that this is the field, right? I want you guys to understand what is the difference between these two terms, okay? Positive versus normative, fact versus opinion, okay? Pretty simple. Um, I'm suggesting, okay, from a perspective of a non-essentialism, uh, non-essentialists would say, look, it's not so easy to separate, right? We can't easily separate fact from opinion, right? What we call facts are highly based on our view of the world, right? What we decide to count, how we decide to count it, and so forth, right? So it's much more muddy than this, right? It's not always clear what is fact and what is opinion, okay? And especially because look, the nature of people seems to be, you always want to extend your knowledge, right? It's very easy to start with something everyone agrees on, start with a fact, but then offer some interpretation on top of that, right? So that you start with fact, but you end up pretty solidly in the realm of opinion. Okay, so many scientific fields uh, have begun to study and embrace complexity. Okay, so begun to embrace complexity, to acknowledge that look, we thought it was simple at first, right? But as we begin to study it, we see wow, there's fewer and fewer fixed constants, right? So physics, we could look at that field. Okay, physics went from a very mechanistic view of the universe, right? The clockwork universe. Okay, so the clockwork universe of Isaac Newton, right? That was the view of the universe. Like the universe was one giant clock, you know. And yeah, okay, it doesn't have gears and springs and whatever that we can see, but it does have gravitation and inertia, right? That the laws of motion that Newton played a role in discovering and describing, right? So physics goes from a very deterministic view, right? Newtonian physics these days is seen as very old-fashioned, right? Very mechanistic, very deterministic, right? Very reductionist, okay? To the modern physics, right? After Newton, we have the theory of relativity, we have the Heisenberg uncertainty principle, we have physics it rejects a lot of the things that it thought were fixed, right? It says, look, time and space and distance, these things are not fixed. We thought that they were always, it was always the case that this distance would always be that distance, right? Turns out that's not true, right? Time and space and distance depend on your inertial frame, right? It's a lot weirder in the universe than we thought, right? Okay, so physics has started to try to embrace a complexity, right? To move towards a non-essentialism, right? We can find the same thing for example, in meteorology, right? Meteorologists thought for a long time that they'd be able to, okay, this is what they thought. They thought they could predict and perhaps even control the weather. Uh, if we couldn't control it, we'd be able to predict it into the indefinite future, right? We'd be able to say, here's what the weather's going to be in 5 years, right, on this particular day, right? So they rejected this, right? They thought this up until about the 1960s or so, but they began to reject this, right? Meteorologists said, we're actually not that good at predicting, especially the further we go into the future. Why is that, right? And they began to conduct kind of thought experiments, right? And one of the things that they argued is like, well, what kind of data would we need about the atmosphere to be able to to actually predict, we need a lot of data, right? We need to know, like what kind of data could we gather about the atmosphere, like the temperature or the wind speed, right? Maybe the barometric pressure. Okay, there's three variables right there that meteorologists are good at measuring, right? Well, here's the problem, right? The atmosphere is pretty big, right? The atmosphere is maybe about 60,000 feet tall, right? Um, the air starts to kind of get thinner and thinner, right? But we, so said that the atmosphere, there's a lot of it, right? We normally live at one particular level of it. Maybe we go up to a mountain or something, but there's a lot of the atmosphere that's unknown to us, right? That we don't measure. So again, we have the same kind of data problem here, right? But the problem that gives us is, of course, what happens in one part of the atmosphere affects other parts, right? I mean, air is air, right? It's all, there's not boundaries between it, right? It's all air. One movement of air, one place causes a movement of air other places, right? Um, and so, in terms of what we've talked about so far, all of the variables are heavily interrelated, right? Meteorologists started to argue, look, we could imagine this, right? Imagine that a very small movement, right? The flapping of a butterfly's wings might, if all of the forces align, right? That little puff of air might lead to a bigger puff of air, right? Other forces moving in the same direction. And we get, perhaps a billion things have to align all together for this to work, but we we end up with a hurricane, right? And the the meteorologists called this the butterfly effect, right? What it means is that small initial changes lead to large final changes, right? Because of that, everything is interrelated. And this is a metaphor for complexity, right? It's a metaphor for saying because everything is interconnected, this is just what makes it unpredictable, right? The butterfly effect is true in lots of it means that we're gonna have to put an X through our idea, right? We thought we'd be able to predict and control the weather. No, it turns out we're dealing with a system that's unpredictable and uncontrollable, right? So meteorology at this time, started to move more towards a non-essentialist view of what they do, right? They've given up the idea that they'd be able to tell you what the weather's going to be in 5 years. Does that mean they're no good? Right? Forget meteorologists. I don't want to talk to them. No, you still want to hear what they have to say, right? They cannot predict things in the future with absolute certainty, but you're still very interested in what they have to say, especially if a hurricane is approaching. Now you want to know what they have to say, right? They couldn't predict that was going to happen, but they're still worth talking to, right? We just have to understand our knowledge has limits, right? And the same is true with the economy. Okay, so as we go through the course, what we're going to see is, again, most of economic theory is pretty highly reductionist, okay? Keep this in mind, right? Notice when we use mathematical expressions, we are saying there's a limited number of variables here, okay? And this always raises the problem of reductionism. All right, that's it for my lecture today. Thank you very much.